So we're going to talk about our last section of notes here. This is 9.5, and we're going to talk about more tests for convergence or divergence. Abbreviate there. So let's see. We want to talk about three things. We want to talk about the p-series test. And with that, one of those is the harmonic series. And then we want to talk about the alternating series test. Okay, so what if we had a question like this? Does the series sum as n goes from 1 to infinity of 1 over n root n converge or diverge? So if we tried to use the things that we know now, if we tried, say, nth term test, that does go to 0, so inconclusive. If you tried the ratio test, my favorite test, we get it equal to 1, so inconclusive. So we need another way to do this. So what we're going to do is we're going to fall back to p-series. So like when we did integrals in chapter 8, we had those p-series. So let's look at that for just a minute. Remember from chapter 8, we had things like the integral from 1 to infinity of 1 over x to a power p dx. And we figured out that all of these kind of work the same way. If you had p greater than 1, the integral converged. If p was less than 1, the integral diverged. And if p was equal to 1, that integral diverged as well. So what we're going to do is we're going to take that integral knowledge and apply it to series. There is a test called the integral test, which you are not responsible for learning this year. And the integral test is sort of the connection between these two, but this also applies to series. So we're going to talk about the p-series test that just looks like this. If I take now the sum as n goes from 1 to infinity of 1 over n to a power p, same rules apply. If p is greater than 1, the series converges. If p is less than 1, the series diverges. And if p is equal to 1, the series also diverges. This one we'll talk about again in a minute here. If p is equal to 1, that's the harmonic series, so we'll do that. But let's go back to our question here. Does the sum as n from 1 to infinity of 1 over n root n converge or diverge? So let's look at that. We're going to look at it like it's a p-series. So it's 1 over n root n. That's really the sum as n goes from 1 to infinity of, let's see, rewrite it as n to a power. That's n to the 1 times n to the 1/2. Add those together, get n to the 3/2 power. So we'd say, all right, 3/2, that is greater than 1, therefore the series converges. So that's all we've got to do is compare it to our rules up here. So this converges since p is greater than 1, done. All you got to do is say it's p-series, p is greater than 1, done. So the p-series test is kind of nice. It's very clear, very cut and dry. You could also look at things like, what if you had a constant times a p-series? Same thing. If you had like a constant here on top, same rules would still apply, because if p was greater than 1 and it converged, it would still converge. So you can use that p-series even if it's multiplied by a constant. Let's look more at this one. What if p is equal to 1? In other words, what if I had the sum as n goes from 1 to infinity of just 1 over n, like n to the first, p is equal to 1. So let's write out some terms of that series. That'd be like 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus dot, dot, dot. When we look at this one, it seems like maybe it should converge, because these are getting smaller and smaller and smaller, these fractions. So maybe it comes up to a total. But what we're going to do is we're going to look at the integral. So let's compare this to the integral from 1 to infinity of 1 over x dx. So with this, we know in chapter 8 we would have said, all right, let's take the limit as b approaches infinity of the integral from 1 to b of 1 over x dx. And we do the integral, we'd say that's the limit as b approaches infinity of the natural log of, I would say the absolute value of x, but these are all positive numbers anyway, so I'm just going to say x, going from 1 to b. And then we'd evaluate, we'd take the limit as b approaches infinity of the natural log of b minus the natural log of 1. And let's see, the natural log of 1, that just goes to 0. So I have the limit as b approaches infinity of the natural log of b, and that is just like natural log of infinity, and that does go to infinity. So it does diverge. So that means that this series diverges as well. So if that makes sense, I'm just thinking about here, quick little graph. All right, graph of the natural log. So here's my graph of the natural log of x. So the natural log of x grows really, really slowly, but it does grow forever. So it does go off to infinity. So that's what we're talking about here. It does diverge. It just does it like as slowly as possible. So this series right here is called the harmonic series. So this right here actually has a name. They call it a famous P series. This is called the harmonic series, and it does diverge as well. So that's our new test, P series test. All right, pretty easy. All right, last we'll talk about the alternating series test in our next video.